The stream is live now. And I'm just we're a couple of minutes early, so I'm gonna rearrange some stuff and notify Twitter that I am now live. If you're watching this on the replay, we'll get into everything in just a minute here. That should be posting. Alright. Excellent. Ooh, my computer is very slow. That's too bad. So I'll wait till the hour turns to noon more precisely. And then we'll just jump right into it. Should got some water. I have coffee, but I'll get water on my first break. Okay, so welcome everybody. If you're watching live or you're watching on the replay, my name is Liz. My pronouns are they, them, theirs. This is a video towards the end of my proposed project to numerize Council of Elders, where I do open signals model development in R. Since the last time, I've done a lot of work off camera, and I anticipate similar before the next final video, because I want to make sure I feel good about how the project is wrapping up, and make sure it has a nice strong finish, and that we get closer to all the goals that I set out. So this time I have done a lot of work off camera, so I'll talk about the work that I did. We have some algorithms cranking as we speak now. We'll see if they finish or not while streaming. If they don't finish, then we'll just continue doing some development and planning while on camera during this 2 hours. I hope everyone's doing really well. I've got a really busy day ahead of me. I have the dentist after this, and then I have class after that, and I gotta get some food right after this, so because I'm gonna not be able to eat for a while following my dentist appointment, because they're doing some fillings, so I want to load up ahead of time. As far as projects that I'll be doing once this project is concluded, I may have some sort of like straggler goals that I work towards even after this project is technically concluded, as per the number of streaming hours from my proposal. But I would like to do occasionally, maybe once a week or once every other week, what I call a special interest study hall. A special interest is a word that refers to some autistic nomenclature. I'm autistic, and I'm working on studying autism so I can help serve the autistic population. But special interest is like something that someone is really interested in and maybe really focused on, and they might know a lot about it or have a lot of practice with it or just really like learning more about it or being exposed to that kind of topic. And so I have all these different projects I want to do. I want to keep doing completely open quant stuff. I really believe in that. I don't think there's I'm not feeling a lot of energy vibing with me on that, but I still think it's important, and I want to continue that work. But I'd like to spread it into other stuff. I want to spread my hustles around. I want to do other stuff, and I'd like to talk about it on stream. And the idea of the special interest study hall is sort of like, if it's something that you can learn from, then come on and listen or ask questions. But if it's, to use another word from a lot of autistic culture nomenclature, if parallel play is your sort of thing, where like you like to sit and do your homework or work or whatever while other people are doing theirs, I invite people to do that. It'd be cool to see if there's any synergy there for people. So without further ado, let me toss up my disclaimer. So this is not investment advice. None of this is. Nothing of me ever streaming is investment advice. I might say I like or dislike something. I might analyze something, and I might give numbers. I might give predictions or show schemes of how I generate predictions that I stake on or I don't stake on. But ultimately, anything you do with your money or your assets or your time is your own choice and is not my responsibility. Please do your due diligence. If you are thinking about putting a substantial amount of money into something and some of that money is your partner's or your family's money, please be sure to talk it over with people who have a stake, and just do your due diligence and try not to get in too deep. Don't invest or spend more than you can in any given thing, and just don't take investment advice from me, because I'm not giving it, and you can't have it. So there's my disclaimer. I'll switch cameras and hop up to the other screen. If anyone's watching this and wants to chat along, I have the chat window open, but I don't have Rocket Chat or Twitter up, so don't talk to me there. I'm not going to see it until later. Thanks for checking this stuff out. If it was useful to you, thanks. I'm glad to have provided something. Okay, so you can also see how dirty my house is right now. So let's turn toward this camera here. So, does it look okay? Yes. Alright. So let's pull up a tomato timer. We'll start clocking away on this. I should have gotten my headphones. Are they around here? No. Well, I might grab headphones in a little bit, but we'll just run it like this for now. Why not? So I opened up a doc here. I think the last one, maybe last couple ones, I may or may not have added to the shared Google thing. I think they weren't particularly valuable content, so it didn't matter to me. But if someone really wants to see them, can get at me on Twitter. I'm at Liz Does It, LIZDOESIT. I forgot to mention, we celebrated, my partner and I celebrated yesterday because we went and bought some cake and some candles, but for the first time, at least as far as I've noticed, I got into the top 100 of some metric on Numerai, and honestly, it's what I consider to be the most important metric is the annual return. So as of yesterday, I don't think things have changed today because there's no scores updates, but I'm 95th in annual return on Numerai Classic with a return of 344% on my model slot named after myself, Liz. Numer.ai/Liz if you want to check that out. I'm super proud of that. Being in the top 100 is tough. I think there's not, some friends I have are up in there and some aren't, and I feel really validated in that. But that's classic. We're talking about signals today, so what are we going to work on? So we want to review the changes that I've made. And I want to talk about it up front too, because part of this project is for me to be able to go back and understand how a project worked for me. And there's some meta stuff happening here, since that's a sort of thing I want to keep doing with projects, and I want to make podcasts about it and stuff. So there was a lot of off-camera work. I did like maybe 20-30 hours of development time off camera, and even more time just spent cranking algorithms, because I was at a spot where, a loop I have made is going to take an hour or two or more to run, and I was running into some problems, so waiting for that to conclude on air doesn't really make sense. Also, we're sort of coming to the end of the project, so we're more focused on having the structure be there, and that'll be what we do as far as wrapping up the project, is distilling a structure that other people can adapt for their own use for using R in the signals competition. So we're focusing more on having a strong structure than on having a good, robustly developed model. This is something to keep in mind if you are going to implement this code and use these models, and please feel free to tell people this stuff is not well validated. We don't have time to set up that kind of thing. I don't want to spend money on AWS to do it. I am just focused on getting across the finish line. So whether or not we make a good model that is validated in the ways that people like is not something that's important right now. It's more important that we just have a structure that people can put their own spin on. And I'm rambling a lot, so let's get back to what we want to try to go over today. So review the changes that I've made. And if anyone's joined us by now, hello. Please say hi in the chat if you're able and wanting to. But in any case, welcome. Thank you for joining us, and thank you for watching on the replay to anyone doing that later. So we want to review the changes. That's a lot of stuff. Honestly, it's probably going to take most of the time. I think maybe let's just make 2 goals for now, and we'll blow them up as we go. So we also want to map out the rest of the project. So I have just to kind of go over before we even pull up the code where I remember jumping out and jumping back in. I've made code that derives its own pricing return and volume return over approximately 20 days, and is adjusted to represent a 20-day return. I've made something that turns the date and the month of the date, 2 for each, to and from, into numeric values, and then I have code that like normalizes everything, so it makes all our, I believe we have 7 columns of predictive variables and 1 target column, if I remember correctly. It normalizes them, so it puts all those columns, including the target, into the range of 0 to 1. And it predicts, it stores the transformations we've made, so we can reapply them to a test set later, which I have not done yet. I'm hoping to do it on camera, but it's somewhat likely that I'll be doing it off camera and just like, building it back into this whole system we got going here. And if anyone's worried about it, I will continue doing these streams until, we have a file that is submittable, and we have a set of scripts that are more cleaned up than they currently are, sort of representing the structure of retrieving the data, modifying it, building a model, and making our predictions. So let's jump into it. Let's take a look at R. We'll get an idea if R is still cranking or not as well. And R is definitely still running, which is fine. Expected. That might be going for a while. I kind of forget how long that one takes. So let me minimize that. We're looking at the very end here. I pasted in some code from some other stuff that I want to adapt for making the test predictions. And once we have that, it should not be too difficult to make live predictions. Let's see. So I'm just going to scroll up a whole bunch. I tested out a whole bunch of models. They're all pretty bad, so we'll take the worst of them and some other ones too, and just slap a times -1 in the front and see how they do on the test set. That's the current plan. Again, this is not a sound strategy for developing strong predictive algorithms. This is just what we're running with. Do more due diligence than that for sure. So let's see. I'm pretty sure we were past this, but I'm just gonna start scrolling through this, get an idea. So we're constructing the day spread. Our input variables are month from, day from, month to, day to, pricing return, and volume return. So, unless I missed it somewhere, 6 actually predictive variables, and 1 target, which would be the target 20-day in the future. So something to keep in mind. Something to keep in mind with this, that it's possible I messed it up when I was setting the code up. You want to check all this stuff for yourself, of course. Is that you need to, if you're going to use the previous pricing return and the previous volume return as predictive variables, you need to make sure you're pulling them in to the right row, to the right date range, the right symbol. Otherwise you will have some leakage or some just completely nonsensical data. And you don't want that. So let's see. All right, so this line here says censure reconnaissance. So I decided to do some data censoring. Um, and for those who don't know, we had a fun discussion about this a couple weeks ago on Daily Scores and Chill, RIP, which about truncation and censoring, both of which were extremely important in my previous career as an actuarial analyst. So data truncation, an example would be when you say, okay, so we have our data set. Say our data set is insurance claims of the automobile variety. And we want to do some models to understand what happens with our reinsurance treaty that applies for losses above $1 million. So to truncate, what we would do is we would say, for the data, variable loss is less than or equal to $1 million. We throw all those rows out and keep everything else. That's truncation. Now, censoring would be, which is what we're doing here. We're not doing truncation, although we are throwing some stuff out at some places, in the interest of having it make sense. Censoring, an example would be if, again, we have automobile insurance loss data for a particular insurer, and that analyst who's working on it, that's us, wants to get get some understanding of that data set, but there's a problem, right? And the problem is that some of the losses, like most of the losses, say are between $1,000 and $10,000. Almost all of them. But some of the losses are like $1 million, $10 million, $15 million, maybe even more, right? Huge stuff that, like, if we want to take the mean, and especially if we want to, like, if we have a reinsurance treaty, right, where it says, like, say, we are Liz Does It Auto Insurer, and we retain all losses up to $1 million. Meaning, if we have a loss in our system, a claim, we'll just call it a loss, say it's already approved. If we have a loss that's above $1 million, then the amount above 1 million, the amount by which it exceeds 1 million, is ceded to a reinsurer that we have an arrangement with. We pay Big John's, auto reinsurance bonanza, a whole bunch of money every year to take all those claims in excess of $1 million, but we still have to cover it up to $1 million. Right? And there's both styles of arrangement I described before are common. This kind of stuff, there's all sorts of arrangements that auto insurers do, and these are just, examples I'm familiar with. So in this case, what we would want to do to understand how these losses affect us as far as our liability to pay out on these losses, we want to say, get an index for every row that has loss greater than $1 million. Okay, so then assign the loss value for every row at that index to to be equal to $1 million. Because we're still liable up to $1 million, and the rest is going to Big John. So now we can understand that data better for our purposes. So I was looking through this signals data, and I noticed that the pricing return could get quite high, but I had a thought, right? And that thought was like, you know what, like, if the return is over 1, if it's over 100%, I don't really care, like, how much it's over 1, and I don't want that giant amount it's over tainting the mean for the underlying, distributions that we might be fitting with models to this. And many people have their own feelings about how models and how approaches should be oriented to this. But, I said, I'm just going to set everything with a pricing return above 1 to 1. So we censor pricing return at 1 or 100%. In my mind, this makes sense. If something is going to have a pricing return 20 days from now that is so high that it's 100% or higher, like, we don't need to really predict how much higher, I think. People might argue if everything's going up, blah, 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 but, I think it helps the distribution understand stuff a bit better. We also, I decided, looking at volume return, which we're not predicting for, we're only using as a predictive variable, but that also would get quite high at times. I looked and saw something like, 95% maybe of the data has volume return less than or equal to 50. So I said, let's just cap it there, and it'll make for a more sensible, underlying distribution that we're using to train these models. I think it's a pretty solid approach, and people should think about stuff like this. Some others might disagree and say they like the raw data. Do your thing. Do your thing, homie. Feel free to adjust it. So then I made the code to, like I was describing before, turning the month to, day to, month from, day from, using the lubridate package in R from CRAN, using functions like month and day. We extract the numerical values. And later we'll put those onto a 0-1 continuum. And I fixed the names. And then I wanted to set up the target. So, like, it's totally possible to use the provided targets from Numeri here. In this case, we did not do that because we calculated our own. And this is, I think the Numeri target might be for after neutralization of the various factors that they neutralize for is applied. So it would make sense to use that target. But we didn't end up using it in this case, and maybe it would make sense for doing multi-target training, which is a thing that Classic is being heavily encouraged to do now with the new data set, new data drop. I'd love to hear everyone's thoughts about the new data drop. Feel free to reach out and let me know. So I start setting that up as the target column, and I just make it be a bunch of repeated NA values with the rep function. And then I loop over each symbol, and for each symbol I loop over each ending date from the date end variable. So in the first stage of the loop, we set up indices symbol, which is the index for all rows with the same symbol as our looping variable L symbol. I use ELL to mean element. And candidate symbol data is just the data from those rows. We're condensing it down so it's easier to work with. And the end date candidates are those unique date end values from that subset. And then we loop over L end is the variable for each end date candidate value. And we say, let me get to the front here so I can highlight the lines I'm working on. We say which date gets which candidate data date end is equal to that end date. And our index of our target for our target is going to be using the intersect function, which I learned how to use. Again, I mean, I've used it before, but it's been a while. From indices symbol and which date, and value target gets the mean of the pricing return over those indices. Because I came up with some like multiple returns here and I didn't feel like really diving into it to figure it out. So I approximate with the mean. And I say index start match end without symbol gets which rows of candidate data value or variable date start is equal to L end. So this is the index that we're going to use for we use the intersect function again with that and with indices symbol for index start match end. And then we have some error checking here where index start match end we set the target to be equal to that value target we pulled out before. And so that's basically, we're saying like, if we have the data where it starts, or we have the, we have the 20-day return over this period, then where it ends, we see, do we also have rows that start on that same date? And if so, that is going to get its target set to that value. This is a part I tricked around with a little bit. It got a little tricky. It's entirely possible that there's some data leakage happening here, or there's some major error I've made. So, be aware of that if you're using this stuff. And then I get rid of the rows with NA target. So I had some comments here I'm going to delete because they don't matter anymore. They're not huge errors. Those numbers aren't the same. I went back and fixed stuff. But basically we're fixing it. We're saying, okay, well, we don't want to try to predict. We don't want to train our model where we don't have a target value. So we just throw that trash away. Easy. Um, now, I also, a bunch of times I made write.csv statements because I'm running these loops. I want to like be able to open it back up, especially in some cases I was running loops overnight, and I would want to pick it back up in the morning if somehow my computer crashed or decided it needed to restart, even though I try to make sure that doesn't happen. Then I have like at least some save files I can pull back up and save myself some time. So again, I mentioned before that sensor point of 1 and 50. I'm gonna just pull up real quick our tomato timer because I think we are. Okay, so let's take a look at R real quick and see if we're still calculating there. We are, unfortunately. um, and gonna do a short break, and then we'll be back. Gonna get some water. Okay, welcome back. I am back. I had some water. Probably need more. Boop, boop, boop. Okay, let's start another Pomodoro and just jump right back into it. Awesome. Okay, I do have audio. Wonderful. Let's bring R back. We'll check on that. Still cranking that algorithm. Okay, so we set the censor point for pricing return to 100%, and we set the censor point for volume return to 5,000%, which is a lot, but makes more sense for volume. Basically, what this code is doing is it's constructing indices to figure out which rows need to be censored for pricing return, or target, because target is based on pricing return, or volume return. And then down here we are performing that censor operation 3 times for each index. And then I write it out. And then there's some irrelevant columns that we drop. We drop the symbol name, we drop, I think there may have been a row identifier that is completely useless, and some other stuff. And I made a function called normalize with inputs named input vector, min override, and max override, where the last two are optional, and apply more for applying the same transformation to your test or prediction data that we did to the training data. So what that does is it converts all those numeric variables to be between 0 and 1. With the caveat that the min override and max override, when applied to like test data, for example, produces ranges outside that by a little bit. And our models seem to be fine with that. So I'm not especially concerned. We make sure to save the transformation, and then we actually perform the transformation by looping over each column in column name, where that's the names of the columns for the cleaned up data. We make a data frame out of it, and we write it out as cleaned data. We also store df transform to preserve what our transformative values are, our transformative parameters are. Otherwise, it wouldn't be the same transformation we'd be doing, so that would be weird, right? And then I wrote some model training code. So I decided to use GBM, gradient boosting machines, or is it gradient boosted machines? I'm not sure. And I differentiated between between model CV10 and model CV100 for the number of cross-validation folds. Just kind of wanted to see how they would differ, and we'll get to that soon enough. In looking at how that went, and I used GBM for some other applications, so I just used it here too. I decided to make the number of trees, n.trees, be 35. We could choose other stuff for this. I don't care. Doesn't matter to me. We are just trying to get a pipeline going here and have people use their modeling expertise and their own experimentation in place of this, so it doesn't have to be good. But other than CV folds, we trained two models side by side that were the same, other than the number of CV folds. And I did this for a number of other values on interaction depth. So as you can see here, and it's the same in CV100, I say interaction.depth equals interaction underscore depth. And up here I say interaction underscore depth is 375. And, it's a bit high. I was ending my experimentation with some numbers that are way higher than it should be, and confirmed later that it did not change the results from the other already very high interaction depth amount. So we tried 1, 2, 3, 4, 5, 6, and 7. I believe 15, 75, and 375 for interaction depth. I just would change this value, and then I would rerun a whole bunch of the code with some slight variations to try to preserve some of it. So we have this. I can probably delete. Oh, candidate test data. Do I already have candidate test data? So maybe I don't need to be running this thing I'm running right now. But maybe I do. I don't know. So this chunk2 function is just a utility. And then we have predictions CV10, predictions CV100. For those models for cleaned test data. I already ran these numbers. Cool. I started duplicating effort, so we'll have a slightly easier time than I had perhaps anticipated. Because I didn't realize I've done a lot of work off the camera, and I got a busy life, so sometimes I forget what I've done. Let's take a look at this. So, chunk to, what does chunk2 do? It's a function that takes x and n. It does splitting. So that's what I use for, like, I do my predictions in blocks. I try to break it into usually 100 parts so I can, like, follow the output and usually not just, you know that feeling when you're, like, waiting for an algorithm to finish and you're like, is this going to be 5 more minutes? Is this going to be 5 more hours? Is this going to be 5 more days? Breaking it up into smaller parts can kind of give an idea of what the rhythm is and how far done it is. And of course there are other ways to get feedback on the screen about how far through a process you are. This is just one of them that I've enjoyed using in my predictive applications. So we say that height is equal to the first dimension of cleaned test data. So clean test data is a thing we have, and I think that's where I was going with this. And then we say chunk size is 100. Rather than 100 chunks, it's like 100 rows, maybe? I kind of forget how that goes. But anyway, chunks helps us section out the data. We say, let me start highlighting stuff so it makes more sense. We say PR is a vector, and prediction CV10 is a vector. And then for each chunk, we increment our index, we print our progress, we calculate the time, and while we're calculating the time, we're setting PR equal to our prediction from, in this case, model CV10 on the clean test data from that chunk. Oh, cool. Yeah, this is great. We're much further along than I thought. And we're just building that with this line here. Prediction CV10 gets C prediction CV10, and then we add PR onto the end, and we loop over that. We print the time. Just go through and through and through. No big deal. And then we do the same thing with model CV100 for each of them. And so I recorded each of these models into names such as model CV10 I7 for the interaction depth equal to 7. What the? Oh. And I would comment, or I would uncomment the relevant section of this when training the model and making the predictions, and then recomment. And I made a mistake somewhere. I think I might have set interaction 5 equal to 7 by accident somewhere along the way. And then we have these predictions here, and we see the correlation of predictions, DF and target. We'll start looking at numbers soon. In just a second here. Let's see. Let's try to tell R to stop cranking since it's doing some unnecessary junk. And then I'll go delete the unnecessary junk and we'll start going over it. Okay. Alright, so I've saved all those models from before as a file called signals.models. In case I want to pull them all out. But let's take a look at my console output so we can... oh, that's right. The up button doesn't work like that in the console. Okay. Okay, so here, this, we'll pull it down just a little bit. This is kind of our big money situation right here. Where we can see how strong our predictions were on the test data. Now keep in mind, it was not trained on this test data. And, you know, since I want to go with something big, I want to find which one of these had the biggest magnitude. If it's positive, we'll go with that. If it's negative, then we'll just do a -1 times that. And maybe we'll try some other stuff too. Just to have a few things to implement since we want to, you know, go somewhere with all this. Okay, so this would be our largest magnitude. -10.1541%. From CV10 with interaction depth equal to 7. Now, if that's a real reflective 10%, that's like crazy high. Super great for us, you know? So good. If we can get 10%, wow. There's no way it's right. It's way too large of magnitude to be right. But I think we're going to pick that as one to mess around with. And now let's look at the correlation of the predictions with each other. Because I think I want us to try that as our basis as model A. And then we want to pick a model B that is very, as much as we can, uncorrelated with model A. And then, and with the same transformations before, we'll throw a -1 factor in front of it. And then a C where we combine the two predictions of those more different ones and see how that goes. A, B, and C, you know, two very different things and an average of the two. So we can see that for I7, for 10I7, our correlations with the higher models are very high, so we don't really want to bring those in. We'll go up a little more. For 10I7 with 10I1 is 66, and then we have 65. So maybe we'll do 10I7 and 100I1 that are, you know, correlated at 0.66. We do have correlations as low as 53. Even 50, yeah, 52.7. I1 with 100I5. It's pretty low, but let's, we want to see how the numbers interact with each other. So we'll do 10I7 and what was it? 100I1. 10I7. We'll call that model A. 100I1. Model B. And we'll say equals -1 times and we'll also note that model C equals 1/2 times model A plus model B. And Nayutan has an a forum post they made about how to ensemble without like there's like if you just do straight up averaging like this, it's not the least biased way, but user Nayutan, Nyuton, made a post recently about how to ensemble and account for the fact that like different predictions have different like bias, weight, and stuff. So that would be worth checking out for anyone who's interested in that. So let's actually set up those models and just like go ahead and save them. We'll bring up the console too. Let me just check my working directory. Okay. Documents folder for some reason, but whatever. So we'll say model A gets we'll call it model A negative because we'll probably I don't know, I think we'll have to make the adjustment after the fact. So we'll say model A negative gets model CV oops, dropping my controllers. And model B negative. And model C will also have to calculate when we are predicting them. So let's say save model A negative, model B negative, file equals negative signals selected dot models. Oh, I misspelled negative. Alright, so we're saving that. Let's see what our time is looking like because I still have not grabbed headphones. We got a little less than a minute. Alright, let's go to. Hello, polynomial. Oh. So we've reviewed the changes that we've made, and we want to map out the rest of the project, which is going to be essentially like we just want to make live predictions and our timer's going off, and we want to clean up our scripts, and that's it. We're so close. We're doing great. All right, let's stop. We'll take a 5-minute break here, and then we'll come right back. All right, we're back, everybody, and my sound is tracking. Wonderful. So, let's start another Pomodoro up there, and we want to talk about making live predictions. And cleaning up scripts is going to be like sort of where we leave it. I think the last cast will probably be mostly just cleaning up scripts, going through and like, this is important, this goes in this one, this is important and goes in that one. Yada yada yada. So this file's getting really long, by the way, and it has a really bad name, like as in like inaccurate about what date it is and such, but it doesn't actually matter, so who cares, right? So we want to make live predictions. So what do we need to do to make live predictions? So I think we kind of want to just like, maybe we'll end like a half hour early and just do that half hour with the next one or whatever. Because there's going to be a lot of cleanup, and I think the live prediction stuff is going to be a lot of boring off-camera crap. So what we'll want to do is scrape Yahoo, updating our historical database, and then we want to using ticker universe provided by Numeri, we want to subset the data, and then we want to process the data. So let's just look at a head. Process the data into pricing return, days. Is days spread one of our? Where's the one where we drop? Well, what's it called when we drop it? All right, let's. We're gonna scroll up a little bit. Okay, there we go. Pricing, return, etc. Oops. Okay, so we want to be pricing return and volume return. Month to, let's bring this to a new line. month to day to month from day from no target so we'll process the data into that. We'll censor the data for at our specified points. Pricing return greater than 1 and volume return greater than 50. Doing this will be a nice little refresher for me too, of like pulling that all this stuff from the relevant parts, which will help for consolidating and cleaning up the scripts later. So we will censor the data, and then we'll normalize the data, and then we will load model negatives, make predictions times -1, make averaged predictions, we're calling that model C, and then I'm getting chills because this is like, this will be it. Then submit predictions. Ideally, it would be great to submit these from within R, but I'm probably going to just do it via a file to start because I don't know how doable it is right now on that. I want to preserve this format a bit. This is I think keeping this information in one place as well as throughout will be useful for reference purposes. Oops. And I'm not gonna, I'm gonna call it a day at 1:30 for me in 10 minutes. Because I think that this part is going to be fickle and annoying and the sort of thing where, like, if I have an hour or two towards the end of the day or random afternoon here and there, it'll make sense to for me to putter through this. Ideally, I'll get it done before next week, so I'll be able to just do cleanup crew next week. But I don't know if that's gonna be the case. You know, school is busy. This stuff is challenging. I want it to be done right. So that's what it's gonna be. It's gonna take some time. If it's gonna take some time. So 3, 4, 5, 6, 7, 8, 9. So we only need 1 digit space to annotate these in this way. So I'm just I'm numbering this. I think I'll decide while I'm doing this if I want to add these numbers down to the actual steps below. It probably makes sense to do that. It'd be more easily searchable, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sometimes I wonder if stuff like this, like I consider myself an old school programmer because I've been programming for 28 years or 26. Anyway, more than 25 years. And I do stuff like this sometimes. Let's say in, yeah, I want to add that. And then it'll be easily searchable, which is just fantastic. I'm getting really excited. I hope some people get some good use out of this, and that some people appreciate the format, which is, I wanted to document from start to end as best I could, production of a model and submitting it to Signals, and I'm cutting some corners at the end here by having a model validation process that is not sound. But hopefully this will be of use to me in the future. Hopefully it'll be of use to other people. I hope the scripts help too. We're getting to that. Okay. Alright, so let's bring up those notes. So making live predictions and cleaning up scripts. So we'll just mark that as done. This is going to be done off screen, and that's going to be final stream 2.5 or more hours. And I want to add to the GitHub. I want to make sure I put that in the put the new code on the GitHub, and I'm gonna grab my phone so I make some reminders to myself about pushing to the GitHub tomorrow, and also about exporting the Twitch video on demand to YouTube. I hope this is useful for people. If it is, please do feel free to reach out and let me know. Also, if you feel particularly inspired and want to donate, I believe the GitHub lists some cryptocurrency addresses where people are free to donate, and you could always just ask me if you feel so moved, but I offer this freely. My cat, however, demands attention, so please make sure to love him. Alright, let me send these reminders to myself. So, one of the pieces of functionality I love about Telegram is that you can schedule messages. It's pretty rad. Okay, so code to GitHub and Twitch VOD export. Set that for tomorrow morning. It'll remind me then. I'll add it to my stuff. Been busy lately. Getting a lot done. It's pretty cool. Let's 9B. That's not correct. So we had our clean test data here. Let's just just to kind of illustrate in these last couple minutes what I was saying about the transformations. We'll look at a head of cleaned data, which is what we use to train, and we'll look at the head of cleaned test data, which is what we tested our models on. We did not train on this data. And then we'll look at some summaries for them. So on the clean data, it should be 0 to 1 for everything. And that is, in fact, the case. But let's see what it looks like when we look at cleaned test data. So in every case, you can see our maximum is still 1. Nice. That's it's pretty similar. But you can see that, at least in the case of the pricing return, the minimum is a negative number. Whoops. That's okay though. Yeah. So next time, might be a week, might be 2. Let's see what I'm up to, what I'm feeling. I'll definitely let Twitter know like an hour before I do it or whatever. Please send me any questions or comments. I'm on Twitter. Liz does it. I'm on Rocket Chat, but not often. Thanks again, and I hope this is useful.